In this video, we will factor out this following polynomial completely. So we have here three terms, 2z plus 1 times y squared, plus the second term is 6, which multiplies 2z plus 1 times y, and the third term we have negative 55 multiplies binomial 2z plus 1. When we look at these three terms, we can notice that this binomial 2z plus 1 is a common factor of in these three terms. So when we start factoring polynomials, our first question is, are these three terms sharing any greatest common factor? In this case, the answer is yes. 2z plus 1 is a greatest common factor of these three terms. So we'll factor this out. And in the parentheses, we have y squared. And then here we have 6y left, plus 6y. And here we have negative 55. We want to make sure we factor this correctly. We can distribute and see if we're going to arrive at the original polynomial. So now we have factored out this polynomial as a product of two factors. The first factor being the binomial 2z plus 1, and the second factor is trinomial y squared plus 6y minus 55. Now our second question is always, can we factor more? So the first term here, first factor here, 2z plus 1. These two terms, 2z and 1, they do not share any common factor, so we can't factor this binomial more. But we can look at this trinomial, y squared plus 6y minus 55. Now, this trinomial is in the format ax squared plus bx plus c, where a is equal to 1. In this case, we are looking for two integers that when you multiply, you get negative 55. So let's say we're looking for two integers n and m, right? When you multiply them, n times m will give us negative 55, and when we add them, will give us middle coefficient here, b. In our case, that is positive 6. Positive 6, yes. The second thing we can look at it is always this c, the c term here. If this is a perfect square, we might have a perfect square here. But 55 is not a perfect square, so we're going to go ahead and look for two integers. When we multiply them, we get negative 55. In order to find this, we can list all the factors of 55. Okay. So the factors of 55 are, we have 1 times 55, right? We have 5 times 11. That might give us the difference of positive 6, right? If we have negative 5 and positive 11, the difference is going to be positive 6. So if we take these two, 5 times 11 will give us a negative 5 times 11 will give us negative 55. And negative 5 plus 11 will give us positive 6. Now what we can do is we can rewrite this polynomial y squared plus 11 y's minus 5y and minus 55. Now what we did is we showed the middle term as the sum of these two terms, 11 and positive 11 and negative 5. So now we have 4 terms in this polynomial, and we can go ahead and group 2 and 2 terms in order to factor the greatest common factor there. So we can go ahead and group them by these two and these two terms together. So y squared plus 11y, the greatest common factor is y. And in the parentheses, we have y plus 11. And in the second group, we have negative 5 as the greatest common factor. So in the parentheses, we have positive y. Positive y times negative 5 is negative 5y. And then we have a positive 11, because positive 11 times negative 5 gives us negative 55. Now we can notice that they share y plus 11. So we can rewrite it as y plus 11 as the greatest common factor times whatever is left here, y minus 5. Y minus 5. So now we have this factor 2z plus 1, and we factor this trinomial as the product of two factors y plus 11 times y minus 5. Yes. Now we have factored completely this polynomial here as the product of three factors, 2z plus 1, y plus 11, and y minus 5.